Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 15th, 2025, just yesterday. This paper introduces a new model series where the 32 billion parameter version outperforms the much larger QN 235 billion model across all math and coding benchmarks. The paper is titled EXAONE 4.0, Unified Large Language Models Integrating Non-Reasoning and Reasoning Modes. And as we'll see, its performance against these much larger models is quite impressive. The authors introduced two main models, a high-performance 32 billion parameter version and a smaller one for on-device applications. And on Hugging Face, you'll find the 1.2 billion and 32 billion parameter models, with usage examples for their unique reasoning and agentic tool use modes. Building on that hybrid attention, this next figure shows another important architectural shift, this time in how the model uses layer normalization. Now, layer normalization, and specifically a type called RMS norm, is a technique that helps stabilize the training process. The diagram compares the old approach on the right with the new one on the left. The key change is that EXAONE 4.0 moves this normalization step to inside the attention block, applying it directly to the query and key signals. This new placement, called QK Reorder LN, is a crucial tweak that improves performance. Okay, so this table lays out the specific architecture for the two new models, the 32 billion and the 1.2 billion parameter versions. We can see that both use the QK Reorder LN we just discussed. A key difference, though, is in the attention type. The 32 billion model uses that efficient hybrid attention, while the smaller model uses global attention. Both models also use something called grouped query attention, or GQA, which is a technique that makes the attention process more efficient by having different parts of the model share some computational work, saving resources. So after settling on the architecture, how do they actually teach these models their skills? Well, this diagram shows their multi-stage post-training pipeline. It begins with something called supervised fine-tuning, or SFT, which is where the model learns from a huge set of examples. Then it moves to reasoning reinforcement learning, or RL, a process where the model learns by trial and error, getting rewards for correct logic. Finally, it undergoes two stages of preference learning to make its responses more accurate, concise, and aligned with human expectations. Alright, so after all that training, how does the model actually perform? This table shows the results, comparing the 32 billion parameter EXAONE 4.0 model against other mid-size and even much larger frontier models. The benchmarks are grouped into categories like world knowledge, math and coding, and agentic tool use. What's really striking here is that in the math and coding section, EXAONE 4.0 consistently outperforms even the massive QN 235 billion parameter model. It also holds its own across the board, showing very competitive performance. Now, this next table zeroes in on the model's non-reasoning mode. This is the mode designed for more general, direct answers. We see the 32 billion parameter EXAONE 4.0 compared against the same set of models. And what's interesting is that even without its explicit reasoning steps, it remains highly competitive. For example, in the world knowledge and agentic tool use benchmarks, it often scores higher than other models in its size class. This really underscores the success of their unified training approach, creating a powerful, well-rounded model. So, to wrap things up, the big story with EXAONE 4.0 is this successful unification of two distinct capabilities, a direct, usable mode and a deep reasoning mode, into a single, powerful model series. This approach really pays off, showing remarkable strength in math and coding, and it's built for the future with its agentic tool use, that is, its ability to leverage external software to solve problems. It's a significant contribution to the field, especially with the models being publicly available. That's all for today's AI Research Roundup. Thanks for tuning in.